Hello again. Okay, this time we're going to look at three problems. We're going to look at molecular and empirical formulas and then percent mass. Okay, let's look at number 52 over here. Now, let's read the question. It says, if a compound is 24 grams of carbon, 6 grams of hydrogen, and 16 grams of oxygen, what is its empirical formula? Now, when we talk about empirical formula, okay, so recall that empirical formula means the lowest and simplest number of ratio of atoms to each other in a compound. Okay, so in order to get this answer, okay, let's look again at what's given. So we got 24 grams of carbon, okay. So, okay, let me write it down here. I'm going to use EF for empirical formula. Okay, and we're calculating empirical formula. Okay, I'll write it down here. There's our E, there's our F. Okay, now let's look at what's given. So we're given three compounds. One is carbon, okay, and that's equivalent to 24 grams. Okay, we have hydrogen, which is 6 grams, and oxygen, which is 16 grams. Now what we have to do here is we have to determine the number of moles, okay, for each compound. So for carbon, okay, you already know this from your previous video. Okay, let's look at carbon. 1 mole is 12 grams. So we're going to multiply it by 1 mole carbon over 12 grams. There we go. And then hydrogen, okay, we're doing the same thing here. Okay, hydrogen is 1 mole is 1 gram. So I'm going to multiply it by 1 mole of hydrogen, which is 1 gram. Okay, and oxygen here, 15.999, that's 16 grams if you round it off. So 1 mole of oxygen here is 16 grams of oxygen. Okay, so same thing that we did in the previous ones. We have to change the previous videos. We're just going to convert now from grams to moles. So our unit, okay, grams, we cancel for carbon. That's 24 times 1 divided by 12, which is essentially 24 divided by 12. That gives you 2 moles of carbon. Same thing here for hydrogen. Okay, that's 6 times 1 is 6 divided by 1. That gives us 6 moles of hydrogen. And then same here. Grams of oxygen cancel. 16 times 1 is 16 divided by 16. That gives you 1 mole. So now you've determined, okay, the molar ratio. All right? Now, in order to find out the empirical formula, okay, if you're looking at all the three groups of moles here, we're going to choose the smallest number. Now, in this case, our smallest number is 1. Okay? So, which means that we're going to divide all these numbers by the smallest number. Now, 2 divided by 1 is 2. 6 divided by 1 is 6. And 1 divided by 1 is 1. So now we've determined your empirical formula. And remember, this is your simplest whole number ratios. Now when we're talking about empirical formula, we're not we're not using any decimal points. We're always using your simplest whole number ratio. All right, so our ratio of carbon to hydrogen to oxygen is 2 is to 6 is to 1. So that means we have 2 atoms of carbon to 6 atoms of hydrogen to 1 atom of oxygen. So when we're going to write down the empirical formula, we have CHO, there's your CHO, we put the 2 here, here's the 6, here's the 1. And because we do not write the 1, that's C2H6O. Now, if you're looking at your answer choices here, there it is. It's letter D. Okay, so, now we can see why A, B, and C are wrong, and D is your correct answer. Okay, that knocks down number 52. Now, here's another question related to that, and this is 55. Okay, let's look at this one. This is a bit different. It says, what is a molecular formula of a substance that has an empirical formula of C2H5 and a molecular mass of 58 grams per mole? Okay, so let's look at that question. Let's break it down. This is number 55. Okay, what's our given? Okay, we write down our given again, and now we have an empirical formula of C2H5, and C2H5 has a molar mass of 58 grams per mole. Now, what is it looking for? It's looking for your molecular formula, which I'm writing down as MF. Now, what's the difference between empirical and molecular formula? So remember, we looked at empirical formula earlier. It's the simplest whole number ratio of atoms to each other. Now, when we're looking at the molecular formula, this is the actual number of atoms in a given formula. Okay? So this is what we're looking for, the actual number of atoms. Now, in order to tackle this, okay, let's look at our given empirical formula. So basically, if you reduce this molecular formula, okay, to its simplest terms, it's going to come out as C2H5. Okay, so let's get the molar mass now of the empirical formula C2H5. So again, we break it down. Okay, carbon, again, going back to the periodic table, that's 12. Okay, 1 mole is 12 grams. Okay, and hydrogen, we all know that hydrogen is 1. And then we multiply it by 2, which is our 2 atoms here in the empirical formula, and this one we multiply it by 5. So that gives us 12 times 2, that's 24, and that's 1 times 5, that's 5. Okay, you add them up, and that gives you 29 grams per mole. This is the molar mass now of our empirical formula, C2H5. Now, if we look at the problem, okay, it says we're given the molecular mass, which is 58 grams per mole. So all you have to do now is divide 58 grams per mole divided by 29 grams per mole, which we got from here. Okay, and 58 divided by 29, that makes it 2. Okay, so basically, in order to determine the molecular formula, okay, it's twice the amount of our empirical formula. So I just write it down like this. That's 2 times C2H5. And just using your distributive property in math, 2 times 2, that gives you 4. 2 times 5, that gives you 10. So our molecular formula, which is the actual ratio of atoms to each other, is C4H10. All right? So look at your answer choices here. Your answer is letter C, C4H10. Okay? Now, if you have a problem like this, all you have to do is just see, right? You can reduce C4H10 to its lowest terms, and that comes out to C2H5. All right? So that's a relationship between empirical and molecular formulas. Okay. Now let's go to our last problem here. And we're looking at number 75. Okay, let me flip over here to 75. This is where we're looking at percent composition. Okay, here it is. Okay, let me see.